All right, in this video lesson, we're going to be talking about a special type of functions which are called one-to-one functions. Now, the reason for this is that in later sections, we're going to talk about what an inverse of a function is. And so one-to-one is kind of what we're using as our building stone for it. We first are going to start with the definition. So a one-to-one function is a special type of function where each output has exactly one input. If you recall, this definition looks very similar to the definition of a function. The definition of a function is that it's a special type of relation where each input has exactly one output. Now we're going to restrict that even further. So for a function to be a one-to-one function, you have to have each output with exactly one input. So everything gets matched up kind of perfectly in a one-to-one function. So let's take a look at some examples of this. So we're going to determine whether each of the following relations are one-to-one. In other words, they have an inverse, which will be important in later sections. And so what we're going to do, similar to what we did when we were looking at functions, is we're now going to just focus on the outputs. Look to see, do any of our outputs repeat? If they don't, then we should be good. And if they do, then that means that it's probably not one-to-one. First, let's just make sure that these are all functions. In fact, if you look at the x values, they are all unique with the exception of this third table, and we'll talk about it in just a moment. So let's take a look at our first table, and let's look at our outputs. So looking at our outputs, 2, 3, 4, 5, 6, they are all unique, which means automatically, just like we would if we were looking to see if this was a function, this tells us that that's a one-to-one function. In our second table, this is not the case. Notice that there's an output that repeats. That output is the value of 1. And notice that it comes from not 1, not 2, but 3 different inputs. So this output has 3 inputs. We need for it to have exactly 1 input. And so no, this is not a one-to-one function. Finally, next in our third graph, our table, we're going to look at first, is this even a function? Because we said that this one was kind of unique. Because notice that it does have some x values that repeat, but notice that those x values go to the same y value. And in fact, that happens kind of every time where there's a repeat. So yes, it is a function. That was kind of first thing we needed to check. Second thing is we're going to check to see, is this a one-to-one function? Because if you notice, you do have some y values that repeat as well. But once again, they come from the exact same x value. And again, here with 2, they come from the exact same x value. So really what's happened is in this table, for whatever reason, we've included a couple of points twice. Like we really don't need these last 2 points or the first 2 points, depending on how you want to look at it. And so it turns out, yes, this actually is a one-to-one function. Finally, in our last table, if you look at our y values, notice that none of them repeat, although you do have some opposites. Opposite of -1 is +1 and so on, but that's okay. Yes, this one actually is a one-to-one function as well. All right, so now we want to do something similar when we're looking at a graph. So we want to be able to tell, is a graph a function and is it a one-to-one function? If you recall, the vertical line test is what we use to determine if a relation is a function. Let's go ahead and do that for each of these 3 examples down below. So if you draw a vertical line and then pass that vertical line through any point of our function, it's only going to cross through once on part A. In fact, it only crosses through once anywhere you draw it on B, and it still only crosses through once as you pass it through C. Meaning that actually, yes, in all of these cases, our original relation is in fact a function. Let's now check the horizontal line test for each of these. So if I draw a horizontal line and then imagine passing that through any point on our graph on part A, it's only going to cross through once. So yes, the inverse is also a function. All right, how about for B? And pretty quickly we get towards passing through twice. And in fact, if you draw it on the x-axis, it crosses through at 3 different places. So the answer here is no, this is not going to be a one-to-one function. The inverse is not going to be a function. Lastly, on part C, no matter where I draw my horizontal line through this graph, it is going to pass through only once. So yes, that is a one-to-one function, so the inverse is a function. All right, so this is a pretty short lesson. Again, the whole purpose of this is to give us some foundation for the next couple of sections. So until then, have a good rest of your day.